Okay, so for question 1, you have a random variable of x with the mean value of x given by lambda 1.4. So this one, there is no event given to you, so you don't need to write the event. You straight away just define the distribution. X is a Poisson with 1.4, and then you apply the formula. So when it's 0, it's easy. 0, 1, 2 is easy. But when I'm saying lesser or equal to 2, then you need to add 0 plus 1 plus 2. Okay, next one. Question 2, same thing, no event given to you, just write down, define your distribution and you put it down, so that shouldn't be a problem. Now if I'm saying h is less or equals to 10, it means it's from 0 to 10, so you need to add 0 to 10, there is no other shortcut to that. Okay, h is lesser than 7, so it's 0 to 6. Okay, because there is no upper boundary, so that's about it. You cannot basically there is no other way to do it. You see, binomial you have two ways. When they say more than this, you can see which is shorter. For Poisson you cannot do that. There is no upper boundary, understand? So like this, like I told you here, see this one, h is less or equals to 10, you need 0 to 10 one by one. Okay, so you can take out the e negative 7.5 and the rest you put it in, but don't worry, in your exams they won't give you something so long. Okay, question 3 is the same. There is no event, so you just sort it out the way you see it. All right. Okay, well, for this one, there will be an event. So you follow accordingly. All right. All right, so number of injuries in a week. Why are we talking about number of injuries in a week? Calculate the probability that in the next playing week, there will be 1 injury, 2 injury, 4 injury. So your event will be number of injuries in a week. You have a Poisson distribution of 2.5. Do you see that? Because this is in a week, they want in a week, so you don't need to change already. It's okay, it's sorted, all right? Then you have question 5. A radioactive substance emits on average 4 particles per second. Calculate the probability that in the next second it will emit. So number of emits in a second, because they ask you in the next second what? So in a second. So the Poisson is 4, you don't need to change because they give you per second, they want per second, no need to change. So you follow the formulas and answer the question. So if you want 0, 1, 2, 3, 4, you add 0, 1, 2, 3, 4, 1 by 1. If they say more than 4 is 5 and above, right? So 1 minus 0 to 4. So 1 minus this lah basically. Okay, question 6. 7 deaths in the last 10 years. Okay, so 7 deaths in the last, that means 10 years is 7 deaths. Use the Poisson distribution to determine that the probability in the next year, so they want in 1 year. So the following year, that means in the next 1 year, what would it be? So if it's 7 deaths in the last 10 years, in the last year was 0.7. Why 0.7? 7 divided by 10, because you want to find 1 year, how many deaths? Right, then you follow the formula and just apply. Shouldn't be a problem. I've also given you the number line here in case. Okay, at the local petrol station, there are on average 40 customers between midnight and 5 a.m. Meaning 40 customers in 5 hours. Okay, midnight to 5 a.m. is 5 hours. So 40 customers in 5 hours. What is the probability that in a randomly chosen 15 minutes? So you need to change it now, right? You need to change it. How do you need to change it? You know 5 hours is how many minutes? 300 minutes, isn't it? 5 hours times 60, you get 300 minutes. So 300 minutes is 40 customers. 15 minutes, how many? Cross multiply, you can find the answer. You will get a lambda of 2. So this is the only different thing in this question where you need to convert the lambda, because your lambda here is for 5 hours. What they want is for 15 minutes. So you cross multiply and you find it, then you apply the formula and calculate the probability. Okay? All right? Okay. On average, a switchboard takes 3 calls per minute during a lunch break. All right? A single minute is selected at random, so you're still talking about number of calls per minute, so your lambda won't change. All right? So after this will be the same. If you have any issues, then you just ask me, okay? To make a dozen, what's a dozen? 12. 12 chocolate chip cookies, you need 50 chocolate chips are mixed into the dough. The same portion is used for all batches if a cookie. So we're talking about only 1 cookie. Just now we are saying 12 chocolate chip cookies, you need 50 chocolate chips. Now you only want 1 cookie. So you need to change it. 1 cookie will give you 4 chocolate chips, okay? 1 cookie will give you 4 chocolate chips. All right? So what is the number of probability that it contains no chocolate? So don't worry, in your exams, they will already state it directly whether they want you to use your lambda as 1 decimal place, whole number, because I understand this might be a little bit of confusion here, because just now I already told you that you can use decimal places. So in your exam, it will clearly be stated to you, so you don't worry. Like here, you see it's stated, also using lambda to the nearest whole number, what is the probability? No chocolate chip. So probability of x equals to 0. So it's just this part, all right? Also, calculate, okay, this part, these two are okay, I think it's quite easy. Calculate suitable probability to show that is more likely to contain 4 than 5. So you calculate probability of x equals to 4, you calculate probability x equals to 5, and you see which is more likely, which is the one with the higher probability. Do you understand? So the higher probability is this one, isn't it? So probability of x equals to 4 is more likely. Okay, customer arrive at an information desk at the rate of 72 per hour. That means 60 minutes is 72. If more than 6 people arrive during a period of 5 minutes, a queue will form. Assume that the arrivals are a Poisson process. So find the mean number desks for a 5-minute period. How to find 5-minute period? You just change it lah. 72 is 60 minutes, right? You want 5 minutes. So 72, you divide 60 first, you find 1 minute. Then you times 5. Okay, or you want to use cross multiply, is up to you. All right. So this question, there is a new concept here. Okay, so I'll go through it here. So find the mean is 6. You should know by now how to get it. Find the probability that a queue forms. How will a queue form? If they say more than 6 people stand in the queue. So more than 6 means 7, 8, 9 and above, right? Do you see the number line here? So more than 6 people stand, there'll be a queue. So now they want to know when there will be a queue. How will there be a queue? So a queue will be when there's more than 6 people, right? So you want 7, 8 and 9. This is Poisson, got no upper limit. So you just take, basically you 1 minus 0 to 6. That is what we are doing here. 1 minus 0 to 6. That means you find this probability here and 1 minus, then you will get 7 and above. So you will get 0.3937. Okay, now estimate the probability that no queue forms in the next consecutive. I need you to highlight the word consecutive. Consecutive 15 minutes means 5 minutes period will repeat 3 times. Do you understand? The 5 minutes period will repeat 3 times. Okay, 5 minutes period will repeat 3 times. Consecutive 15 minutes. If they say consecutive 20 minutes, the 5 minutes will repeat 4 times. So first of all, before you use the word consecutive, you need to find the probability that there will be no queue. How will there be no queue? If they say more than 6 people stand, only got queue, right? So no queue should be 0 to 6, isn't it? So no queue is 0 to 6. So x probability less or equals to 6. That means it's this part, which we already found here actually. You have it here already. So it's from 0 to 6 here. Is 0.6063. Okay, this is for the next 5 minutes lah, basically. Okay, this is for the next 5 minutes because we not yet used the word consecutive yet. So now when they say next consecutive 15 minutes, it means 3 blocks of 5 minutes. That means 5 minutes, 5 minutes, 5 minutes, repeat 3 times. That is why you take that probability to the power of 3. So if they say consecutive 20 minutes, you take it to the power of 4. Consecutive 10 minutes to the power of 2. Understand? So the word consecutive tells you no need to change the lambda. You just power it according to the number of times it's repeating. But if the word consecutive is not here, then you must change the lambda from 5 minutes to 15 minutes. Do you understand or not? Okay, I'm repeating. The word consecutive is there. You no need to change lambda. You just power it to the number of times it's repeating. But if the word consecutive is not there, then you got to change the lambda. Understand?